Hello everyone. Today we're gonna learn how to determine a positive integer number n is a prime number or not. So this is our problem. So I'm gonna demonstrate how to use a for loop by using this problem. Okay, so let's look at some example. For example, we have a number 5 here. So the number 5 have only two divisors. The first one is number 1 and the second one is number 5 itself. So we can say that this is a prime number. Or for example, we have a number 7 here. It's similar. We have number 1 and number 7 are divisors of the number 7, or similarly number 11. But you can look at number 9. Number 9 have three divisors. The first is number 1, the second is number 3, and the last one is number 9. So it is not a prime number. Or we can say number 2. Number 2 is a prime number, and this is the smallest prime number we have. Okay, this smallest. So this is smallest prime number. And look at number 1 here. Number 1 is not prime number because it doesn't have a true divisor. Alright, only one. So today I'm gonna show you how to use a root fork solution. Root forks, it means the most simplest naive solution, but keep in mind it's not an optimal one. But usually, I mean, in the normal case, we can easily figure out the root fork solution. And based on the root fork solution, we can try to find an optimal one. Okay, so how we can do that? So we know that a prime number have only two divisors. So we can try to use for loop to count all the divisors of n. If the total number of divisors is equal to 2, so we can conclude it's a prime number. Okay, so we can say if the total number of divisor is equal to 2, so we can say that n is a prime number. Otherwise, it's not. Okay, before we move on, let I review some very important principle of for loop. We have a range function here. So when you apply range function with only one input, it means you want to go through from the value 0 to n minus 1. We can have mathematics notation similar to this one. So we can call this one a half interval. Okay, half interval. And next one is this is range n minus 1. It means you want to move from 0 to n, because you know that we always stop at the value stop minus 1. Okay, as the previous lecture we have discussed together. And finally, we have a range from here. It means you move from the value star, here is star, and we have a stop e n plus 1, so we will move from number 1 to n. So it's a half interval. And other case here, we have a step value equal to 1. Okay, so it's the most important principle. I hope you still remember. Okay, so let's look at some example. We have a handy example here. We have number 5, step 1. So we're going to go through the for loop. So at the first iteration, we have the divisor equal to 1. So the counter value the number of the number of divisor is equal to 1. Okay, because we just figured out this one, number 1. Next is the number 2. So for number 2 is not the divisor of number 5. Okay, of n. So the total number of divisor is still number 1. And so on, move on until we hit the number 5 here. So it's number 5 is the divisor of itself. So the total divisor will become number 2. Oh, I'm sorry, it's number 2. Okay, so that's it. It's enough. Let's go through the implementation. So we end here. Enter by signature number. You can see here. It's a very normal step. And then we have the count variable. It's actually represent the total number of divisor. Okay, so we go through number 1 to n plus 1, and then we're gonna check if this divisor variable is a divisor, actually a divisor of n. By using this expression, we're going to increase the total number of divisors by 1. You can see that. And after we go through the for loop here, we're going to check if the total number of divisors equal to number 2. So we can conclude that n is a prime number, otherwise it's not. So that's anything we need to solve this problem. Okay, so let's try this program. Scale it and let's enter number 7. So number 7 is a prime number. That's it. Let's try with number 6. So it's not. So it's right. And then we have number 1. Number 1. Yeah, it's not. Yeah, 100% correct. And let's try with number 2. Yeah. So it's enough for today. Hope to see you next video. Bye.